Welcome back, Math 30-1, to your sixth lesson of exponential and logarithmic functions. In today's lesson, we're going to look at the laws of logs. Now, if we just look at them here, we'll notice they're very similar to exponential logs, because really, logs are just the inverse of exponential logs. Okay? So before, if we have multiplication, that's the same as adding two logs, right? So if there are two things being multiplied, it's the same as separating them and adding them. Okay, when we separate them. So it's kind of the opposite of adding. When we're multiplying two things together, that creates adding. Here, when we're multiplying, it's going to create adding. Okay? Well, kind of the same idea. Here, adding creates multiplication. Now, let's look at the quotient law. Here, if I have m over n, that's the same thing as subtracting. Or I can combine these together to get division. Okay, so subtraction is division, multiplication is adding. Very similar in a way to our exponential laws, to our exponent laws. Now, so here's class example number 1. It says evaluate the following using the product or quotient law. Alright? So I look at this, I don't know what 2 to the power of 12 is in my head. Or 2 to the power of what is equal to 12. I cannot solve that. 2 to the power of what is equal to 3? It's going to be a decimal. I can't solve it. So what am I going to do? Let's try using the quotient law. They're subtracting, so I could divide them. So that's the same thing as log base 2 12 divided by 3, which gives me log base 2 to the 4. Now 2 to the power of what is equal to 4? 2 to the power of 2. My answer is 2. Easy. Let's take a look at the next one. I have a combination here. 6 to the power of what is equal to 9? I can't do that. 6 to the power of what is equal to 8? That's very difficult too. 6 to the power of what is equal to 2? Can't do that as well. It's nice. They're all the same base, so we can combine them. Just like exponent laws. If they're the same base, we can combine them. So let's combine these together. This means multiplication. It's going to give me log 6, 9 multiplied by 8. Then we must divide it by 2. So that's going to end up giving me 36. Log 6, and we have 36. Well, I know this. 6 to the power of what is 36? 2. There we go. We are done. So now let's look at our next one. Here we go. We have used the laws of logs to write the following as a single logarithm. So we want to simplify. It's kind of like simplifying again. Back to simplifying. Okay. I have this here plus, what does that mean? Multiply. But we do my brackets first. So I have log, and what is that? X10 plus log x75, subtract, do this brackets first. So I'm going to have log x2 multiplied by 3. Okay, so that's done first. Okay, so here I can multiply these, so I'm going to get log 10, and this is base x, 10 multiplied by 7.75, divided by, because subtraction, divided by 6. Which gives me log x, and we're going to have 750 divided by 6. Okay? And that can be simplified a little bit more to log x, and we'll have 125. Okay? So that's it. Something to the power of something is equal to 125. Alright, now evaluate if x is equal to 5. So we're going to get log 5 to the power of something is equal to 125. That's going to be 3. There's my answer. Alright, easy. But before, if I have this 5 there, that'd be very difficult to do, wouldn't it? Okay, let's take a look at number 3. Use the laws of logarithms to solve the following as a single logarithm. So these are my negatives and these are my positives. So we have log b, and we're going to have 2 times 3. So 2 multiplied by 3. Okay, we're done with those. Then I want to subtract 6. Okay, so I divide by 6. And then I must divide by 8. 8. There we go. Both of those are division. Nice. So now let's simplify this. This is going to be, this and this can cancel off. So I'm going to get log b 1 over 8. That's my answer. Okay? Now it says evaluate if b is equal to 2. So log, we have 2, something's 1 over 8. I'm going to get, well, I know 2 to the power of 3 is equal to 8, so then 2 to the negative 3 is going to be equal to 1 over 8. There we go. All right, let's take a look at the next one. It says the expression log 2x plus log base 2 to the log base 2 2x minus log base 2 x squared minus log base 2y is equivalent to what? So we have to simplify this. Let's find what it's equivalent to. Put it into a single log. All right, so let's add. So we're going to have log 2, then we're going to have 2x squared. Interesting. Then we're going to have to subtract x squared. Okay, so that's division. Then we subtract y. Then we subtract y. Now I look at this, we're going to have this and this. Those cancel off, don't they? So I'm left with log 2, and we have 2 over y. Now I'm going to expand this here, okay? Because I look at this, that's not there. So I'm going to expand this. This is the same as log 2 minus log 2y. Now 2 to the power of what is 2? 1. So that's 1 minus log 2y. Is that one there? It's at the bottom. So my answer is D. Okay? So notice that I expanded here. I looked, that's simplified, but there's nothing there. So then I expanded more, and I said that's equal to 1, because this is division, so that's a subtraction. Okay? Let's take a look at my next one. It says, determine the value of 3 log base 2, p subtract 3 if, p subtract 3 log 2q if p over q is equal to 8. Okay, so we know p over q is equal to 8. So let's first combine this. This looks very messy and ugly. Let's see if we can combine that, okay? So I have 3 of these and 3 of those. Well, they are not the same, so I'm going to try factor out of 3. Okay, so I'm left with log 2p minus log 2q. There we go. Now I'm going to combine these because I factored out that 3. Makes it a lot easier. So I'm going to have 3. Now for subtracting, that's division. You get log 2p over q. Well, we said this is equal to 8, right? Now we can solve that. So let's go ahead and solve it. So I'm going to have 3 log 2 to the 8. Well, what is this equal to? This here is equal to 3. So I have 3 multiplied by 3, which is equal to 9. And there is my final answer. Okay? Let's take a look at my next one now. So now we're going to here's an investigation on the product law, but we're going to get it a little bit more. So the product law is, or a power of a power. What do? We multiply. Okay? Power of a power, remember, we multiplied the power. So here, for multiplying, that's the same thing as we bring that to exponent. It's a power of our number. Okay? So it is very related to exponent laws. The power law and exponent laws meant multiplying. Here, power is multiplying. Okay? So let's try this here. What is this the same as? I can put a 12 in front. I'm going to have log 4, 16. So 4 to the power of what is equal to 16? Before, I'd have to go 16 to the power of 12. I cannot do that in my head. I could go, I know 4 to the power of something is equal to 16. That's squared. So it's 12 multiplied by 2. Because this here is equal to 2, which gives me 24. That's a lot better than going 16 to the power of 12. I cannot do that in my head, but this here leaves it simple to do in my head. 10 to the 21. Now that's a lot of zeros, so I'm just going to go put 21 in front. And I'm going to have log 10, and then we have to the 10, which is 1. Right? This is 1. So we get 21 multiplied by 1, which is 21. But also we know this is 10 to the 10, so that's going to give us 21 anyways, because that was our definition from before. Anything to itself is 1, which gives us exponent. That's it. Okay? All right, now let's take a look at the next one. Simplify the following. Well, this is the same as n is equal to log 6 to the 6, which is 1, which is n. Nice. But we've done that before. We already did something like this, just a little bit more complicated, but this makes it nicer, using the product law to simplify. Let's try this next one. Well, this next one here is a little bit more tricky, isn't it? So let's say 6 to the power of log 6n. Okay, so let's write that out. Second. Okay, so now I'm going to say this is equal to x. We know it's equal to some kind of x. And I can't solve for this exponent. My problem is my variable's in my exponent. So when my variable's in my exponent, what must I do? That's simple. I must isolate it, but we're going to have to log it because we can't isolate the best we can, so we're going to log it. So I am going to go log space 6 to the x is equal to log 6n. Okay? Oops, that should be n. Alright? Because 6 log base 6 to log base 6, this is equal to that exponent. That's all I did there. Now, let's try and solve this out here. Oh, I get x is equal to 6. Or x is equal to n. So this is just equal to n. That is just my solution. Okay? That's it. So I know this here is equal to n. Because this must be the same as that in the logs. Alright? So from this, we could come up with two other laws that whenever we go like this is just going to be equal to n. At the base, it's always equal to n. And those are two other laws or identities that you could use to help you solve things faster. Or you could just go this way and do it the long way, but memorizing these could help you solve it a bit faster. So that's everything in this lesson. Hopefully you understood it. As I see you tomorrow, if you have any questions about it, feel free to ask tomorrow as we tackle these together.